Yeah, as I said, welcome to everyone. Great to have you here for the, I would say, new fundamental. That's totally enough. It's not only, or it's no longer a hands-on training, I would say, but there are some parts we can work together. So that will be possible. And yeah, one of the first and important information is that this training will be recorded. And here we have the two trainers, Marcus and me. Marcus will do the first part of the training, a small 45-minute introduction to MicroStream, the architecture and stuff like that. And I will do all the technical stuff and the programming stuff. And I will show you how to use MicroStream in a proper way. And that leads me to the timetable, Central European time, of course. So we start at 5 o'clock. We have a small break on 6:30 to 6:45. And then we go until the end. Then we have enough time at the end for Q&A and yeah, stuff like that. We have Florian at the end also in the training because we released the version 8 today. And I think it's great to see what are the new features of MicroStream, what new features do we have, and Florian will do a small introduction to the new features of version 8. That's also great. Okay, let's go to further information. So basically, as I said, the sessions are recorded and you will get access to that recordings afterwards. So after the training, you will get a mail where you will be able to download the videos. And it's also, you will also be able to get all the projects that we create within the training via my GitHub account, and you can download it. Most important, the questions. Ask as many questions as you want. That's important. So whenever you have a question, feel free to interrupt me. And maybe some question, I will move some questions. Maybe if it doesn't fit that, then I will move it a little bit, but I will not forget it. So here are some links that could be helpful for you. So basically,
I cannot see your screen.
Oh, thank you, Marcus.
You're also very beautiful, but perhaps it will help to share your screen.
Of course it will. So here it is. Now you can see my screen. So, so as I said, sessions are recorded. You will get material, questions you need to ask, and links. We have a lot to GitHub, to the documentation of MicroStream. Some training examples will also be available. And there is another important point. If you need a certificate, you will get one if you fill the form on this link. Then you will get a certificate. Of course, I will do that in the end. Let's talk about the topics for today. So as I said, we start with a short introduction to MicroStream by Marcus. Then maybe we have, if we have enough time, I will also try to do a performance demonstration, a little bit more detailed one, but not sure about that. It depends in how fast we are, how many questions do we have and stuff like that. Maybe at the end, if we have enough time left. So then we will do the demo. But we start with MicroStream with a quick introduction, a quick demo with some explanations. Then I want to talk about a proper data model. That's also important because some of you are working with relational databases for sure, and without Hibernate maybe. I've talked a lot with people which are using relational databases and they don't use Hibernate. So in some parts that might be important to talk about what is a proper data model and what how should you create your data model, especially for MicroStream. Then we want to talk about step-by-step configuration of MicroStream, what has to be configured. I will use a Micronaut project for that, and most projects are Micronaut projects in that training. So, but no worries, I will explain the most stuff you need to know to start one of these projects. Then we want to talk about the CRUD operations. So the deletion, the create objects, read and update and stuff like that. Then we also have to talk about queries and how to use Java Streams API. Some of you might not use this before, so that could also be helpful to you. And at the end, we do a small introduction to our new cloud cluster. And we do a deployment together to the cluster also. And then you can access the part or the cluster which is deployed there. So that will also be great. Okay, so that's it so far from my side. With that, I can hand over to Marcus for the short introduction, if there are no questions so far. Okay, as far as I can see, there are no further questions. Then Marcus, you can go on.
Thank you so much, Christian, for your introduction, and hello everybody, wherever you are now. So we are super international. That's awesome, and because the last weeks we were exhibitor in Atlanta at the DevNexus, we were at the GeekCon in Krakow in Poland. So I've seen some people from, I guess, from GeekCon also joining. Awesome. And I'd like to jump a little bit into the functional principle of MicroStream. And here the first slide, you can see I talk about MicroStream and Eclipse Store fundamentals. It's because MicroStream becomes now an Eclipse project. So we have announced this at the DevNexus and GeekCon already. So MicroStream is now divided into two Eclipse projects, Eclipse Serializer and Eclipse Store. So this is pretty new, and I have mixed the slides a little bit, so I was not able to complete all of my slides. Sorry about that. So I talk about MicroStream in this course because it's called a MicroStream training. But on some slides you will see already the term Eclipse Store, so it's the same actually. My name is Marcus Kett. I'm CEO and co-founder of MicroStream. We are with my team. We are a contributor to various open source projects. We are developing Java for almost 20 years now. We have built Java development environments and worked on the JBoss Hibernate tools to improve database development with Java, with Hibernate and caching tools like EHCache for many years. So we have a strong background in also relational databases, Hibernate, and persistence in general. And this is also the reason why we started the MicroStream project around 10 years ago. So yeah, that's our team and some team members, the people behind the MicroStream and Eclipse Store project. And so we all love Java programming and working and improving database programming with Java. We also at various Java conferences, and so we love conferences, getting contact with the Java community and getting feedback. And if you want to give us feedback, this would be the best salary for us. So if you like MicroStream, star us on GitHub, please, and give us feedback. And by the way, please ask questions, so many questions you like in the chat. So here are the people who write the code. Christian is the project lead of the cluster team, and Florian, our CTO, will also join to to introduce you to the new great features of the latest MicroStream version 8 we have released today. All right, so we as a team started, as I mentioned, creating Java development tools. This IDE is, of course, still available. It's called Rapid Clips in version 11. It's also open source under EPL. The whole framework is open source, and MicroStream is part of this development environment. It works like Visual Basic, but for Java. So this was the initial idea, and this was also why we worked on improving database tools for Java. But now this course, of course, is all about MicroStream. Version 8 is now released. So it's not already in Maven Central, so I would expect that tomorrow it will be available for download. So what is MicroStream in a nutshell? MicroStream is a Java persistence layer or persistence API, persistence framework. It is similar to Hibernate, but on the other hand, completely different. So it stores data, but not in a relational database. So it allows you to store any kind of object, any object graph, any complexity, any size, any Java types, whatever you build, it can be stored by MicroStream. You also can store individual subgraphs, not only the entire object graph. So mostly only changes in subgraphs will be persisted, and it allows you to store your objects in any storage, in any data storage that is able to store binary data. So plain files or specific binary binary data storages like AWS S3, for instance, but also traditional databases, because traditional databases are able to store binaries. But it's very important to mention that we don't use a database model anymore. So we don't use the specific functions of a database. We just serialize the objects on disk and don't use the object relational model, the relational model or any other database model anymore. So we don't use it. And vice versa, MicroStream allows you to load your object references and mostly subgraphs into the memory and restore the object graph in memory. The object references are automatically merged into the object graph, so you don't have to deal with object copies. And the entire concept is fully object-oriented, which means there are no more classic selects. So just call get methods, and the engine loads the object reference and cares for the rest. That is the functional principle and idea behind MicroStream. It is tiny open source Java library. You can download via Maven Central. You can just include it into your project via Maven, and the code is available on GitHub. So here's the repo. So if you like MicroStream, it's super important for us if you start us. So this is great for the entire team. MicroStream is already part of Project Helidon, which is one of the most popular microservice frameworks on the market. And thanks to the Helidon team, so Dmitry Kornilov at Oracle, he said only 1 month after we have open source MicroStream, yeah, let's integrate MicroStream into Project Helidon. It fits great together. It's a great persistence for microservices. And last year also Micronaut integrated MicroStream. So we are also part of the Micronaut framework. We are member of the Micronaut Foundation. and sponsor of the Micronaut Foundation and work close together with the Micronaut and the Helidon team. And also other frameworks are currently working on integrating MicroStream. MicroStream is not a demo or kind of like test framework or something that comes up very new and experimental. It has started almost 10 years ago, and it's in production use for many years at various enterprises. And it worked so great that we decided 2019 to found a company and to provide MicroStream as a professional project and open source project. So far, MicroStream version 7 was the latest version. As I mentioned today, version 8 is released. And I also mentioned already, MicroStream is divided into 2 projects. MicroStream Serializer becomes now Eclipse Serializer, and MicroStream Persistence becomes Eclipse Store. So yeah, sometimes I talk about MicroStream because I'm used to talk about MicroStream, but I also will mention the term Eclipse Store. And also we're working on a new standard similar to the JPA standard, because of the functional principle of MicroStream. Eclipse Store should become a Java standard. So, and I don't think that it's too complicated, but perhaps sometimes it can be confusing. In the upcoming month, we will have both versions available, so MicroStream and Eclipse Store. And the reason is that the release process at the Eclipse Foundation is more restricted than we are able to launch MicroStream, which means now MicroStream 7 becomes Eclipse Store version 1. And at the same time, we have released MicroStream version 8. So both releases will be available, and MicroStream version 8 then will become Eclipse Store version 2. And then MicroStream development will stop, and then we will continue with Eclipse Store version 3, 4, and so on. And here's the big picture. So we create a new standard. We have the reference implementation for this standard with Eclipse Store. And Eclipse Store is built for being a single JVM storage to run Eclipse Store, to run MicroStream in only one JVM process. If you want to build distributed applications, then we have built a cluster solution. It's called MicroStream Eclipse Store Cluster. It is available on-premise hardware and also as a software as a service. All right, so the big question is, why do we need actually a new persistence? Because we have JPA, we have Hibernate, and I like to talk about a little bit about the challenges and the functional principle, and why we why we believe we can improve this and provide a better solution for Java. But in the end, it's your decision. And in a microservice world, in a microservice architecture, perhaps you don't make a decision for only one technology. There are mostly a mix of technologies. So use this solution that works best for your use case. So in Java, we love object-oriented programming. We love type safety and great object models. We all talk about all the time about clean code. So, and the problem here is when we want to store data, then everything is completely different. So then we leave the Java way and we use an external system that works fundamentally different from Java, a database. And of course, the databases were invented in the 1950s, so they were already standard when Java came up. So this is the reason, of course, why we store data in databases. So we are used to use databases. The problem is that Java as a programming language is completely incompatible with the relational model. So we talk about impedance mismatches, and we have several impedance mismatches. So like the object model can be much more granular than the relational model. Then subtypes are not possible in relational models. So, and also data type differences. So with Hibernate, we have always challenges with these data type mappings. We are not able to store all Java types easily. We cannot build our object model freely. We have to adapt our object model to the relational database. So, and also through runtime, queries have to be generated behind the scenes, and object have to be generated by the framework behind the scenes. And this always leads to latencies, to very, very expensive latencies. And with the NoSQL databases, we have pretty much the same challenges, because the NoSQL databases, they are not relational databases anymore. They introduce new formats or data structure like JSON. So it's very popular to use JSON or XML. And then the graph databases came up. So also graph databases are very popular. Column stores or key value stores, object-oriented databases. And now the vector databases are very popular. But all these data structures are also incompatible with the Java object model. So we have here the same challenges as well. We have to adapt our object model to the database model through every single read and write. And to solve this problem, JPA was invented. Hibernate is the de facto standard, and that works. So it's a common technology. It's used almost everywhere. But this is very expensive, because we have these mappings through every single read and write, and this slows down our queries and leads to higher complexity. So, which means object relational mapping or data conversion behind the scenes is expensive. To accelerate database queries, we are used to add a cache. Here, by the way, there are great articles in the internet, of course, about impedance mismatch. To accelerate database queries with relational databases, then we are used to use a local cache. So then we can accelerate our database queries. But the complexity of our system will increase. Here we can see this is one instance of a JVM process of our app or microservice. In practice, we very often run distributed applications, which means multiple instances of our application or our service. Then there are further challenges with this kind of architecture, because as soon as we change data in one of these instances, then this instance is in sync with the database. But the problem is that the database is not in sync with all of the other instances of our application. And this leads to further challenges. So how to solve this? Yeah, well, now we can put the cache between the application and the database. And this should not be a single point of failure, which means we need a distributed cache cluster between our application and our database. So the complexity increases more and more. And when the load goes up on the database, of course, we need database replication. And this leads to really high complex architecture, 3-cluster architecture, and this is common. So the question is, yeah, can we simplify this architecture because this is very expensive? And also the database costs and the cloud database costs are skyrocketing in practice. So most IT divisions have challenges with storage costs. Why? And that's because let's assume we need 250 gigabyte PostgreSQL as a service at AWS. So it depends on the machine you use. But if you have a 4-core machine and with a 16 gigabyte memory, you pay around $80,000 for one instance. If you need replication and share the load, high availability, then with 3 nodes, you pay around $26,000 and so on. So a database as a service is expensive, and we do not talk about database licenses here because we use PostgreSQL. And the cloud vendors now, they provide us cloud binary data storages like AWS S3. And in comparison to a database as a service, S3 is more than 99% cheaper. So 250 gigabyte costs you around $70 a year. So it's more than 99% cheaper. And another question is, can we combine all of this? So improving the way we store objects and we use objects and how and where we store our objects in the cloud. And this is the idea behind MicroStream, to use the binary blob storages of the clouds. And here are some facts about Java. So when we worked on the relational database tools, and we saw that, of course, Java actually is super fast because we have the JIT compiler, so it optimizes your Java application, and it becomes really super fast because in-memory computing with Java is very fast. So we have the JIT compiler, great. We have the best data model in Java because we have object graphs, and the database vendors are focused on inventing the best data model. So as I mentioned, some introduce key value, they are focused on graphs. New databases are focused on vectors. But in Java we can do everything. So we can use everything. We have already the best data structure, object graphs, and we can use collections. We can use all Java types. So this is already a multi-model data structure. Perfect. And also for searching and filtering, we have a great query language already. So we have the Java Streams API. We have GraphQL. We can search on an object graph in microseconds. So when we compare this with the traditional JPA query, Java Streams API will be, in the most cases, 10, 100, or even 1,000 times faster than a JPA query. Why? It's because everything is executed in memory. Here we can see reading from the memory directly. It takes only 250 nanoseconds. In comparison, when we read data from a disk, it takes 20,000 nanoseconds. So we talk about milliseconds, 1000x faster when we are able to read data from memory or execute algorithm in memory. The only piece of puzzle missing in this game is Java does not provide a storage function. Storing data on disk is not possible in Java. And MicroStream is the missing piece of puzzle in this game. And there is already a functional principle or architectural pattern for that. It's called system prevalence. And there's also a very nice Wikipedia page where you can read about this functional principle, and the architecture pattern is very simple. So it says just keep your data in memory, because we assume memory will be very cheap in the future. Then just create a snapshot of your system state and store your objects by creating a snapshot persistently on disk. This pattern was created around 15 years ago, but there are some challenges because memory is still expensive in comparison, and the amount of data is also exploding. So which means memory is still expensive. So creating a snapshot of the entire system state is not really cool. So this is the reason why this functional principle is not that popular so far. But with MicroStream, we have now solved all of these problems. So we create micro snapshots. We create only a snapshot of the changes. And here is the principle how it works. So what we did with MicroStream is, let's have a look inside a database. And it's very important. So inside a database server, we can see there, of course, is storage. So because the database has also to store data, mostly in a binary format, sometimes in a human readable format, persistently on disk. On top of that, there we have a database management system. It cares for validation, business logic. It cares also for concurrency and stuff like that. And also here, memory is very important. So the more memory you have in your database server, the faster your database will be. So memory is important. On the left side here, we can see our Java application or service instance. So now what we have done, so we add Hibernate in the local cache, of course. So, and what we have done, we replace Hibernate or any other mapping between your app and your database. We replace Hibernate or data conversion with MicroStream or Eclipse Store. And we keep the data in memory. We execute everything in memory, which means we don't need the local cache anymore. So we can skip the local cache. And now the architecture gets really beautiful, simple. And because we have the data in memory, we query the object graph in memory. So we don't need a database management system anymore. So we have to care for all of this, but in Java we do it anyway. So mostly we care for validation, for optimistic locking. So we skip the database management system, and we don't need the memory on the database server side anymore. The only thing we keep is storage. And we need a binary storage. That's it. So we have a performance demo, and it shows how fast it is. You can see the performance demo on our website. What about distributed applications? So back to our distributed application architecture, which means we replace the application or microservice traditional nodes with a MicroStream JVM nodes. And now we are able to replicate the object graph through 100 or even 1,000 JVM processes. We keep the data in memory, which means we don't need a cache anymore. So we have already a distributed cache when we replicate the object graph through multiple JVM instances. So, and because we store data in a blob store, you can use, of course, plain files, but they are not managed. You can do that. They are very fast, but it's recommended to use a blob store like AWS S3 because it's fully managed. They provide you uptime, They provide backups. They care for data center replication. So we don't need a database cluster anymore. We don't need the machines anymore. We can skip them. So only one binary data storage is required. We have the data memory. We replicate the system's data memory. We can skip the distributed cache. And the end result is a really plain, beautiful, tiny architecture, core Java only, and everything is super fast and easy to implement. Apologize for always using the word super, because 1000x is really super fast. All right, there are two kind of application cluster we can build with Eclipse Store MicroStream. So with this replication, we can replicate our application nodes or microservice nodes. But we also can run such a cluster in between our storage and our stateless microservices, for instance. So you then can also build your stateless applications, stateless microservices with Java. You can run AWS Lambda, for instance. You can also build Python applications, if you like, and query a MicroStream cluster. So this is also working by using REST or GraphQL. As I mentioned, you can choose your storage solution. Plain file is very fast. So very often we are asked how fast are write operations. And when you use plain files, you have almost the performance of your disk drive. So it's very, very fast because there is nothing in between. There is no data conversion. There is no mapping. So this is very fast. Of course, a blob store like S3 is slower. So it depends on use case, what you're using. If you have to use Oracle in your organization, you can keep it. Of course, it can store binary data. MicroStream runs wherever Java runs. The really only requirement is Java version 8. And now with MicroStream version 8, we switch over to Java 11. It also runs with GraalVM native images. And of course, you can use all JVM languages, and it runs on Android as well. What you can do with MicroStream, we can use it for your microservices. You can use it with serverless functions, but you also can use MicroStream in monolithic application, big memory machines, because initially it was built for monolithic applications and big memory machines. The more memory you have, the faster your application will be. And keep in mind, you will save a lot of memory because you don't need a database cluster anymore. You don't need a distributed cache anymore. Put the money into your application nodes and buy a little bit more memory, and you will get a super fast application. All right. So there are also some rules and challenges. So we also want to talk about challenges, and please ask questions. This is very important. So on the left side, we can see a traditional database server paradigm. The database, which means your data, are stored on a database server. The queries are executed on a database server. This is completely different with MicroStream, because with MicroStream, you only have storage, plain storage. Database is now executed within the same JVM process as your application or microservice. And your database will be an in-memory database, and we search and filter with streams on the object graph. So this is a paradigm shift in database programming. So we have to think a little bit different and to rethink database programming. In the end result is There are also challenges, but mostly benefits, because you can use POJOs, you can build your object model freely, you can use Streams API, you have 1000x faster queries, but perhaps in some use cases also can be challenges. And one of the most popular questions is, do I need as much memory as I have storage? So which means if I have a 1 terabyte database, do I need 1 terabyte memory? No. If you have a lot of memory, that's great, use it. Please use memory. Then your application will be very fast, so you can avoid I/O operations. So use memory. But if you have not enough memory, this is not a problem. It also works with AWS Lambda with 512 megabyte memory size. It works also because we have lazy loading. So it depends on the use case. If you have enough memory, use it. There are also some further challenges with MicroStream or Eclipse Store. It's because it's built for Java developers. It's a kind of like storage function for Java. So it's built for Java developers. It's not built for DBAs. There is no SQL support so far. And of course, you have to be, you need some experience with core Java. Functional principle. Some minutes for the functional principle, how this works. So I mentioned already, you can build your object graph freely. You can use all Java types. You can store only one object. You can store a list in your object graph, but you also can have very complex object structure with circular references. So really complex graphs. Everything is possible and supported by Java. You don't have to implement serializable, by the way. This is very convenient. The only thing you need to get started is a MicroStream instance. So let's have a look into the memory. So we create a MicroStream instance. Christian will show the code. And then we need a root object. And we need some POJOs, and then we can add objects to our root instance just by storing objects or by creating objects and then storing objects persistently on disk. So, but the first step is we add some objects to our root object. You can add a simple object, you can add collections and so on. And then we call a store method, and MicroStream creates the binary file and adds the binary file to the file storage. So we create some further objects and store these objects, and MicroStream creates another file, which means we never overwrite data. So this is different to a relational database. Also, updates will be stored, appended to your file storage. So whatever you do with MicroStream, your storage will grow. So we add some more objects here, and we store these objects with calling a store method, and MicroStream will store your object, append it to your file storage, and so on. Of course, we can also change objects. So let's change here some objects, and then we call store method, and MicroStream will create a new binary file in your file storage. But only the changes are stored. Only the delta is now persisted. So what happens through system start? So we start the application, and through system start, MicroStream loads the entire object graph into the memory. But it's very important at this point to mention that only the object IDs are loaded. only object IDs, no data are loaded. And you as a developer can now define whether you load also data initially into the memory or not. So you can, there are two options, eager loading and lazy loading. If you do nothing in your classes, it's automatically eager, and MicroStream will load also data into the memory. If you define your classes as lazy, MicroStream will only load the object IDs. And then we can load object references by just calling get method. So get customer, and MicroStream will load the object reference and will update your object graph in memory. So this is very convenient, fully object-oriented, no more classic selects. So by using lazy loading, the only thing you have to do is to use a wrapper class, and that's it. We only use POJOs. There are no, by the way, there are no interfaces to implement, no superclasses. There are no annotations. We really work with plain POJOs. So, and we can now operate on our object graph. We can load data lazy, we can update objects. Everything else is done by the engine behind the scenes. And of course, now we can search on our object graph by using Streams API. This is very easy. And at one point, of course, we have to change classes. And this is also a great question all the time. What happens if my classes change? Then MicroStream provides a so-called legacy type mapping. But I guess Christian will explain this into more deep. So let's assume we change here some classes. MicroStream loads the object, the related object into the memory. Then MicroStream compares the loaded object with your class. And if there are changes, then there is a heuristic that recognizes all these changes and can solve this problem. So if you add fields, if you rename fields, if you remove fields, this is very simple to use. So these are the easy cases. And even if you change data type, primitive types, the heuristic can solve this problem. For more complex cases, you can define a legacy type mapping, and then you will store the updated object into the file storage. And as I mentioned, we never override existing object in the file storage. We will store a new object into the file storage. So which means now we have two versions of our object in the storage. We have a new version and we have an older version. And you can define whether you want to keep your older objects or not. If you can also define that MicroStream garbage collector removes your legacy objects from your file storage. Here we can see we have numbers of legacy objects in our file storage, and now with the MicroStream garbage collector, we can remove the objects from the file storage. And this garbage collector runs in its own thread and behind the scenes and cleans up your storage all the time. So this is the functional principle, but Christian will show, of course, the code. We also talk very often about I/O performance. So how fast is I/O? So, well, I/O is the slowest part of MicroStream because we cannot change this. This is physics. So avoid I/O operations. You can avoid this because, yeah, add a little bit more memory. You can save a lot of memory. And to accelerate I/O operations, MicroStream provides you channels. Channels are actually threads. And so I/O operations can be executed in parallel by using channels, multi-threaded. The more cores your architecture provides and has, the more channels you can use, the faster I/O operations will be executed. In terms of memory management, it's very important to mention, you don't have to care for memory management. So everything is covered by the JVM, by the garbage collector of the JVM. You can use lazy loading, and in terms of lazy loading, you have full control about your lazy references, so you can clear your lazy references if needed. You can also define timeouts, but you don't have to care for memory management actually. So, and in case of garbage collector issues, don't have to worry about this, because the modern JVMs can also manage terabytes of memory sizes trouble-free. For instance, the OpenJ9 and especially Azul. And this is the reason also why we work close together with Azul, because if we can provide you a fast JVM, then your MicroStream application will be fast. And it's very interesting. So we have done some performance tests together with Azul, and we found out that the latest Java versions are much faster than older Java versions. So only by updating your JVM, you can accelerate your MicroStream application tremendously. That's great. And also with now the upcoming Java version, Java will introduce virtual threads. So, and with virtual threads, your MicroStream application will also become more performant. So we have tests where we have proven that the performance can be improved by up to 50%. So that's really great by doing nothing, just to update your Java version, and you can accelerate your in-memory database applications based on MicroStream. All right, so this is the functional principle roughly. Are there any questions? Christian, have you?
Yeah, I tried to answer most of them, but wasn't able to finalize it.
Okay, cool.
I'm still working on it.
Awesome. So I also try to answer some questions, and please take the chance, ask questions, give us feedback. If the functional principle is super cool, so that's great to hear, but also if you have doubts, and also would be very interesting and valuable for us, tell us what you're doing with MicroStream, what you have in mind, where you have performance issues, or where is a problem to solve. So this is very important, because we have to learn from users, from you guys, to improve MicroStream, and to build a solution that is really able to solve your problems. All right, then I'd like to hand over to Christian. Thank you for joining. It was a pleasure to see you again virtually, and hopefully we see us at the JCon conference in Cologne, or on other Java conferences. Thank you.
Okay, thank you, Marcus. So as I said, I tried to answer as much as possible, but maybe some answers will be given in the next few parts of the training. So let's wait for it. So first and most important, let me share my screen. That's my IDE. That is great. So I also some of you wanted to say the performance comparison to another database, and we created one more detailed performance example. And this is the architecture of this example. So what you see here is we have a setup with 3 EC2 instances, and at the left side we have one EC2 instance with MicroStream as a storage engine. There is also a Micronaut application which provides REST endpoints to get the data. And on the right side, we have also installed on an EC2 instance a PostgreSQL server. And there is also one Micronaut application which loads the data from the PostgreSQL and provides the same data also via REST. We compared this or we measured that two instances with Prometheus and a Grafana board, and now and of course we need one sender application that sends the requests and measures the responses. Okay, so this is the example application. This is the sender application, and there are 4 different tasks that can be started. The first one is just a really straightforward call of give me books, and there are 1,500 books with title and author and ISBN. Really straightforward. It's a quite flat structure of books, and we can start this. So now the sender application starts to fire the requests to the different servers, and during that I'm able to share you the Prometheus and the Grafana board, and now you see what happened on these 2 machines. So of course it needs a little bit to get the average and to see what happened there, but so we see at the beginning we have 220 requests per second on the PostgreSQL side, and we have 425 on the MicroStream side, and for sure we have to wait what happened with some more requests. So there are some. Can you see my screen? That's important. So
yes, we can see the screen.
Okay. So
When you use your IDE, Christian, you please zoom a little bit that we can see the code.
Okay. That's great. Thank you. So let me just decrease the resolution so that would be helpful to you. Okay, now it should be a little bit bigger to see, and you will be able to. Okay, now this is the maximum requests we can send. So you see the comparison on a flat data structure. I think important is the amount of milliseconds for the books on the PostgreSQL side. We have 167. And on the MicroStream side, we are at 2.76 milliseconds for the request. That means, yeah, a lot more and a lot faster than on the on the MicroStream side. And what is also really interesting is the amount of CPU that is used on the PostgreSQL side and on the MicroStream CPU on the EC2 machine. I think that's quite impressive. Even when we use of course you would say, okay, MicroStream gets the data from RAM, and that's the comparison is not the best. Let's change this. So let's use also lazy on the MicroStream side. So that means MicroStream has to load the data again and again from the hard disk of the EC2 instance. I would say it's the same like on the PostgreSQL side. So let's start this task. Then we have to switch to the lazy caller. Let's see what happened there. Yes, it is. It is multi-CPU. Yes. Don't ask how much. I don't really know, but okay. Now you see the differences. So as I said, MicroStream has also to load the data from the hard disk, and we changed this because we disabled the cache on the PostgreSQL side, so there is no caching mechanism in place because we want to load the data directly always from the hard disk. And now you see the differences to MicroStream. I think that's really quite impressive how much faster it is. So, and I would say, last but not least, let's have a look to a join call. So what happened if the queries are getting bigger and bigger? Let's just have a look. This is a join rest call, 1,500 books with stores, addresses, and shop names, and try to join everything. So let's start the task. Let's go to the join call. And I expected that we will see max CPU usage on both systems, because that is quite heavyweight to load all the data. Hopefully that works now. Okay, now that's right. So we have heavy workload on the CPU because both systems has to join all the time. And we have at the moment currently 5.2 seconds on PostgreSQL and only 685 milliseconds on MicroStream. I think that's quite impressive. So to see the differences. On the left here, as I said, we have the amount of calls per minute. So I'm pretty sure there are a lot of details we can talk about and discuss about, and it's always quite difficult to create proper comparisons or proper performance demonstrations. But I think the basic approach of this one is quite clear. So it's MicroStream, of course, has to be much faster because of its architecture and the way that MicroStream works. So but it's yeah, interesting to see that. And this is also the same experience. So when I'm working around 5 years now with MicroStream in different projects as a project manager, and I think that's always the same. It's definitely much faster and than other applications. Okay, so on any databases. Okay, so any questions to that performance demonstration? So let me just stop it. We don't need this anymore, I guess. So let's close it. Okay, so then let's go on with some code. And as I promised, I want to start with a small example to give you an idea how MicroStream basically works and how to use it. I'm pretty sure there are many different ways to use MicroStream, especially with Spring Boot and Helidon and Micronaut and stuff like that. I will use the easiest one, the straightforward one that will work in any Java project. But yeah, as I said, there are many different many different ways to use MicroStream. I created are you able to see the code? So let me just open the code maybe so I can increase it. So okay, that's the code. Is it okay for you to read this?
I would say yes, Christian.
Okay. So let's start with, as I said, with the easiest way to use it. So I created a small Java application with one main method. And the first thing you have to do is you have to add, of course, you have to add the dependency. So that means the very, very important dependency is the MicroStream storage embedded, because MicroStream is part of your application. So there is also a Gradle dependency you can add That's totally up to you. You can find everything in documentation, but we need to have this MicroStream stored embedded dependency. That's the first step. And then we are able to initialize our first object, and the most important one is the storage manager. The storage manager represents the database itself, and we have to initialize it with some informations. So yeah, it's version 7 at the moment, because version 8 is, of course, it is available, but especially for that example, I will use, or for the training, I will use version 7, because it's the last well-known working version. I could also use a version 8, but not for the training on the first day. Okay, so embedded storage start, and there are two important information I have to hand over to the start. The first one is the root object. So whenever I use MicroStream, you need to have one object which is the top object of your graph. So there are possibilities to have multiple top or root objects, but this is not the point here in that example. And it's enough to have one. And for that reason, I create one object which is called my company, and it's the root object of my graph. Let's switch into it. So let's see what's inside. Okay, at the moment it's empty, but let's add one collection of customer. Let's say a list of customers. I would say the easiest thing to store multiple customers. There is one customer entity here. So with a mail, a name, and first name, really straightforward, just the objects like in Java, pure Java POJOs, I would say. Again, the root object with one get customers, and let's go back to the main method. Okay, here is the storage manager. Now let's create some objects. When we start up the application, we need some objects. So that in that case, I create some customers. Domain is the right one. Yes. So here we have our customers. I created 2 of them. The next step is to add this customers to the customer collection. That means I used my root object. There is also the possibility to say, okay, let's ask the storage manager. So I will be able to say, okay, storage manager dot get, or let's say root, yeah, root dot, and then it enables me to storage manager. Just a second. I have to find the right method, but that's not important for now. So, okay, let's access the root, get the customer, and then we add these 2 customers to the collection. And there is a very important point of MicroStream is what object has to be stored. So that means when we add some customers, of course, there are new objects, and mostly you are used to store the new objects. But in case of MicroStream, you have to store the object which has changed, and this is really important to know that. And in our case, we changed the collection because we added 2 customer objects to the collection, and that means we have to store the collection itself. In my case, it's my company, which is the root object, and then we say get customers. Then I say store, so that means storage manager dot store, and that's it. And just to improve if this happens, I want to do a system out print line through the root object and see that everything is working great. So okay, so let's start the application. Let's say run as Java application. Okay, now you see John Doe, and this is really, yeah, that is nothing special. We get the export, and now on the second try, we just disable these lines to create. So what we have now is we have only the storage manager in place, and see if the data is still available. So let's start again. And now you see the two stored objects are stored to the MicroStream storage. So you would ask, okay, where is the storage? Where is it stored? How can I find it? As you can see here, the second parameter of this method was path get data. So that means I stored it directly to the hard disk. It could also be a persistent volume on your container or stuff like that. In my case, it's the hard disk, and you will see this within the project. So when I say refresh, then you see there is an additional folder created. And here are the two most important files of the storage itself. So let's just jump into it. Show a System Explorer. Okay, so here we are. So let's go into the data. You see two different, one file and one folder. So first, we have the persistent type dictionary. That is the dictionary where all the different types are stored within a MicroStream. So when we open it, then you will see there are some, yes, here it is. You see all the possible types which can be stored within MicroStream, and also our type, which is created, our specific type, the type of customer, is here with its object ID and object type ID, sorry, and yeah, it's our customer. So we need that persistent type dictionary to read out the storage, and then we have the channel file. And the channel file or the channel folder, it contains all the data itself. So you see there is one channel file, which is the data file. And there is another file, which is called transaction. That is because MicroStream needs that transaction stuff in the background. But the channel file, or the channel 0 file in that case, contains the data itself. Okay, so any questions so far? That is a really quick introduction to how MicroStream works. What is the functional stuff of MicroStream? It's quite easy to use. There is one question from Guy. When using multiple channels, when increasing the channel count, we will have more channel folders, right? Yes, that's right. So it depends on your, so some people ask always, okay, how many channels do we need? So basically channels are very useful when it is important to write data to the hard disk in parallel, and then it helps to have multiple real threads or cores of your CPU, and you should choose the right amount of channels which fits best to the amount of CPUs you have and the amount of cores you have. So in my experience, you should choose something between 1 and 8, I would say. I think that's a good amount of channels. Most of the time we use something between 2 and 4. That's totally enough. The more channels you create, the more the data is split up to the channels, and it might lead to a slower performance because MicroStream has to collect all the data from the different channels. That in some cases that is not useful, but I think something between 2 and 4 or 8, that's a good amount of channels. And it has also be in 2, 4, 8, 16, and so on. That's how it is working. But you could find everything to the channels within our documentations. Okay. Does that answer the question? Okay, great. There is another question. Are the data stored on the .dat file encrypted or protected with any security mechanism? No, it isn't. So it's a feature request that exists in our issue tracker, but there is not sure if we would implement that. Maybe I have to talk with Florian. Maybe there are a lot of people asking that, but encryption is basically up to you. So you have to encrypt the data and store it to the hard disk. It's not in an encrypted way on the hard disk, but maybe in the future we implement a feature like this. Of course it could, yes. That is because data has to be decrypted and stuff like that, and for sure it will increase or decrease the performance, definitely. Okay, some more questions. Log4Java. Can you be more specific on that? Okay, I knew what you mean, but I think it's the right version or the newest version. There is another question: using more small file sizes, more small file size, the store I/O will be more higher. I think I never used. I didn't change the file size most of the time I use the default one and it works great for me. So there is no need to. Maybe you have a really special case, then it's better to you to increase the file sizes, but I think it's not basically recommended to do that. Okay, let's move on within the training. Basic example, I think really straightforward, nothing special in it. Let's talk a little bit about data structure. So that brings me to my next presentation. Proper data model. Just let me check. There is another question. Does the primary key ID like in JPA is mandatory when creating the object? Okay. So no, basically not. We don't need any primary key anymore in a way that JPA uses the primary key. It makes not sense. It makes no sense to have let's say a technical primary key that nobody knows and just to keep the data consistent. It's more about to have a business primary key, let's say an email address or stuff like that, to really identify your data. But a primary key in a way like JPA, it's not needed anymore. In some parts it could be helpful. Then most of the time we use stuff like UUIDs, for example. That helps sometimes, but it's not always needed, or I would not recommend to use this on every project. So, okay, let's talk about the proper data model and a little bit about comparisons to the relational model and what are the pros and cons of those models. And also, let's talk about how to handle bidirectionals, for example, or what are bidirectionals, why to think about that, and how does the graph influences the UI. Basically, we have these two different structures. We have the relational models, and we talked about we have primary keys and foreign keys, and we think about have data in a table. Yes, right. So we have tables and tables of customers and companies and cars and stuff like that. And we have on the other side, we have the object graph, which is the part of the Java side, I would say. And now let's talk about the differences. So when we talk about the relational model, we talk about stuff like we have frames and doors, and as I said, seeds, and it's kind of like to have data in a warehouse. So that's the same. And with the foreign keys and primary keys, we have to plug the objects together with a join. So whenever we create a select, we have to join the data to get a whole object, right? So this is basically how it works. On the object graph side, we have this structure. As I said, we have a car, we have tires and seats and doors, and that is why we always talk about why to use object-oriented programming languages. That is because we want to have objects like in the reality, and I think that's the right thing. So when we talk about a car object, we have all the information within that car object, and that makes it easy to handle data. So we have a car, and tires are directly attached to the car itself. Also the seats and doors and stuff like that, that's also attached together. That means whenever I touch a car object, I have a whole car, which is easy to use within the programming, in the world of programming. There are some problems on the relational side. First of all, data within a table are incomplete. That's for sure. That's also we need to join data, but within the table it's incomplete. The funny thing about relational model is that informations about the relations are absolutely necessary within the code, and because that's the reason why whenever you write a select, you always have to do the joins again. There is no special way to get the data without the joins, and you always have to know the joins and how they are related and stuff like that. Even when you have all the informations in the database, because most of you would say, okay, it's quite important to have the constraints within the database. Constraints are quite important because the database needs to know which table references to another table and how they stay or how they are binded together. That's important, but that's not for us as a developer. We don't have any advantages of that constraints. We have to create the join informations again and again. I don't like that system basically, because most of the time it makes no sense to have that. Why to separate the data nowadays? As I said, the graph looks like the real world, and relations are directly defined within the node. That helps a lot. As I said, the Java object car represents a single car with all the informations in it. And yeah, let's do some considerations regarding the data model. So let's talk about an n-to-1 relation or one-to-many relation. So in that case, we have a car and it belongs to a brand. And it on the other side, we have one brand and there are many cars. So we could do it in this way. So we can have a brand with a list of cars on that side here. And we have on the other side, we have car with one brand in it. Or we could have stuff like this. We can have the brand and with a list of cars, or car with a brand. What possibility would you choose? Which one? What do you think? Which one is the right for your application? It depends. Okay. The first answer is the best one. So yes, you're right. It depends. So it depends on your data structure. But let's think about your database. For example, your relational database. Are you able to realize both sides, especially with Hibernate or stuff like that? Is it possible to have that? on the database side? Guess not, right? So because you have a car, you have always this part, right? This part is the database side, but on the object graph side, you could have both. Yeah, that's right. On the object graph, and you need to have an OR mapper in between to get the data in the right way. So you can have both of this, but it comes with a lot of effort, especially this construction below here. You always have to take care about caches and stuff like that. Whenever you change the brand of a car, then you have to see that you have to add the car also on the other side to the list of cars within the brand. So to keep the cache up to date and stuff like that. So it's a huge effort to have this this combination within Hibernate, for example. So, but you are right, it depends. And that's also the point where we have to think about, okay, it's also the case on the object model. You also have to think about, okay, how to create the object. Do it in this way or in this way. And this is one point. Is it possible to have a car without a brand? That's an important question. And whenever you have this structure, then you would say, no, it is. So we are not able to have a car without a brand because, yeah, the car isn't part of this list of cars here. So this is not possible, but on the other side, it is. So that's the right answer. That is because the right answer is depends. It depends on your needs of your application. What about this? What about if we have some UIs? So that means data structure influences your UI model or your UI structure. And most of the time, you have forms like this. We have an article, we have a price, and we have a category down here. And that means we need a list of categories here to select one. And in that case, it seems that the category is a part of the article or the product. So, and that means maybe some framework features of the UI are no longer usable. That could also be a part, especially when you use stuff like Vardin or other UI frameworks. They work better with other structures. Another example, what about this one? So find the category of a product, especially when, so let me just check this. So we have a list of categories, or my category has a list of products, right? So get all categories, stream over it and filter, and then I get the products contains a specific product. Okay, yeah, that's right. So that in that structure, we have a list of categories, and each category contains a list of products in it. So that is how we could find a category in that case. For one case, this is great. But what about this grid, for example? Imagine that you want to show the category directly to the product. And then this could be a nightmare. So because this is not working for 500,000 rows, for example, you have to do that again and again. That will decreases the performance enormous. And that's what I'm talking about. Find the right object graph, find the right structure for your application needs, and not for the database needs. And that's the point, I would say. Okay, so bidirectionals they are also part of the, or could always a part of the object graph itself. And you have to you are in charge to keep it consistent also on the object graph. That's also interesting. Does it need more memory in the RAM if we have, for example, let's say we have a list of cars here, and in addition, each brand has a list of cars here. Does it increase the memory, the RAM sizes? What do you think? I would ask that question later again. So when we talk about directly to think, what about if you say, okay, let's say we have a brand with list of cars, but we need also a pure list of cars in the end. Does that increase the RAM on the application side? That's right. It's just another object reference. So we need, of course, the reference itself needs a little bit, but not the object itself. So that's good news, especially for MicroStream. But yeah, as I said, a huge amount of references can lead to a huge amount of RAM. Keep in mind, MicroStream is an in-memory database. Okay, let's do an example. And let's say, okay, we are a book selling company with multiple bookstores, and we are selling thousands of books a day to our customers. What most important nodes/tables do we need, and how the relations would look like? That's interesting. Let's do this together. And I created, of course, I created the solution for you. Maybe it's not, but let's see. So basically we need our company. So there is one root object, you remember? So one company, one root object. So we need the company. Then we need somewhere, we need our books somewhere. We need authors somewhere. As we said, we have multiple bookstores. So we need stores. Then we need our customers, of course, addresses, always, cells. That's also important. And we have employees. So I would say these are the two important, or the 8 most important nodes or tables within the database. And now let's check how these objects belong together. So we have the company, my company, and of course it needs an address. We have a list of stores. Each store has a list of books and authors. That's what the stores have. So the stores have the books, and each book has an author. Every store has cells, of course, and employer or employees, and each employee has an address. Of course, the store itself has an address, and my company handles all the customers, and of course the customers, each customer has an address. So let's check this. How does it look like on the Java side? So I also created this data model on the left here. Let me just close this one. Okay, so we said that we need one root object, and my root object in that case is the company. The company, let me just put this aside. So as we said, the company has an address. It's that object. We have a list of stores and a list of customers. By the way, this is not the best way to handle the data, but I would say especially for those of you who have never created an object model in that way, I think it's quite helpful to see that. Let's jump into the store itself. So what happens in the store class? So we have a name of the store, of course, and you can have many of thousands of strings and stuff like that within the store object. But we said, okay, each store has its own books. We have cells in the store. We have employees in the store. And this is how an object graph grows more and more. And this is how to work with objects. So we have an author, and sometimes it makes sense to not bind them together for some reasons, but let's talk about this later on. Okay, so as I said, you will be able to set up the data structure for your needs in your application. And I think that's the point behind. I explained that before. You don't have to create a data structure for the database itself. Many people ask me, okay, how can we do a migration from relational database with Hibernate objects, I would say, to a real object structure like this, or especially for MicroStream. So, and I always answer, okay, so when you use Hibernate, there must be an object structure already in place, because you need the receiver objects for Hibernate, of course. So, and therefore you will be basically able to use this object to use this object, especially for MicroStream. That's basically possible. So in that case, you will be able to merge the object one by one when you want to switch to MicroStream. But it's not the recommended way to do this. So I think it's a good way to do this is to start MicroStream together with the Hibernate connection, and then transfer the objects one by one and migrate it during the copy process. And then at the end, store the root object and everything is fine. Okay, so this is basically how a Java object structure looks like. But there is one question which is quite interesting. What about if we delete? What happens when we delete a book in that case? So let me just step into one book object. So we have a store, and each store has its books. What happens when we delete a book? What do you think? What is one of the biggest problems when we delete a book in that case? By the way, as a question, because I read it, MicroStream is compatible with Lombok. Yes, you can use it. Delete is removed from collection. You are right. That's for sure. But what happened in addition? So let's say we have 3 books with, or let's say we have only one book with one author in that collection, and we delete that book. We also lose the author, and of course the sales will be in problem. So we don't have that book anymore, and it might be possible that there are some troubles with references for the sales. But I think the most important point is when you delete the book, you will also lose the author. And in some points, this is not the best way to do. So that means we need to find a way to store the authors in addition. So how can we do that? Yeah, it's quite easy. Why not to create an additional list of authors within our company? So that means let's create one list of authors. And that's also the reason why I ask, is it a problem to have multiple objects in different collections? It's possible. So of course you are in charge to handle or to keep it consistent, of course, but it's definitely possible. So if there are needs to have the authors in that way, then you have to use it like this. So it could be possible to handle that in this way. Another problem. What about if you need a list of all books on the market? Of course, it's possible to iterate through all the stores and get the books out of the stores. That's possible. But I think that's the same. It's the same problem. When we delete one book, it's no longer available. So it could be sometimes it's necessary to have books in the same way, like with authors. So let's do like this. We have books. and now you can see the problem. Now it looks a little bit like in a relational database, right? So we create additional lists of books and authors, and you are right in a way. Sometimes it is needed to have that. But what about if these books are thousands and millions of books? Then we have a problem, because we always have to iterate through these books. There are many different possibilities to have that. For example, we could use stuff like that. Let's create a hash map instead of using a list. And let's say, okay, we have a string which is used as an index, for example. And copy paste is great. I love it. So let's call it books2. So let's import the hash map. Okay, that could also be a solution for you. And most of the time, that helps a lot. So that gives you, this could be one solution, or there is another one, which is this one. What about this? That seems also be interesting, to have a structure like this. And of course, you could also use a tree map. Yeah, that's true. I think that's one of the biggest advantage of MicroStream. Just use the right structure for your needs within the application. You don't have to create, or you don't have to use data structure which fits best to the database. Just use the structure you need in your application. And sometimes it's necessary to use a structure like this, for example, or an index. Let's say the string consists of the first 2 letters of the ISBN of the book, for example, and then you have a list of books which is not that big sized, and you will be able to find a book much faster than in an array list, and you don't have to iterate through an array list again and again. And in some parts that helps a lot. Okay, but later on we have more examples about this, and especially on the advanced training, we talk about lazy stuff in deeper, and then there are more informations about how to create, or the best practices of creating a proper data structure. Okay, a lot of questions I have to answer. Where to start? So let me just check. Where can to start? Genau. The first question I remember is how to distribute the object graph between multiple JVMs. It's not a question related to the data structure, but every storage manager belongs to one storage, and it's not possible to connect one storage with multiple JVMs. That's basically the basic rule of MicroStream within that version. So it's not possible. Whenever you need to access one storage with multiple clients, you have to provide the data via REST or using Micronaut as a data storage server and stuff like that, and provide the data via REST. That's what we basically recommend. But there are ways to do that, but I will come to that later. So Next question. Can I have more than one root object? Basically, yes. But when we look at this data structure, for example, or just go to the company, let's go. Yeah. You can see you can have multiple collections within your company. I did a lot of projects in the past, and as I remember, I never used more than one root in one object, in one project. Sorry. I think it is possible, basically. So you will also be able to initialize multiple storage manager, and therefore it's possible to have multiple roots. And I'm sure it is also possible to have multiple roots within one storage manager, but I would not recommend this. I think it's okay to have one storage manager with one root, and if you need another one, create another storage manager. It's not that much memory overhead with an additional storage manager. Then we have another question. Sales would be a problem. That you should have multiple root objects. Now that's what I explained. It's not necessary to have multiple roots. Only one root is enough, and then you can have multiple collections below that one root. Is it possible to use tree map? I already answered this. Yeah, of course, you're right. Hash map is implementation, use map. Okay. Don't hesitate me that much. A UUID, yes. Are some objects not allowed to be stored by MicroStream, or can we store any JDK and custom object? You can store any JDK objects. There are no restrictions as far as I know. What I would recommend, do not store third-party objects because of version changes and stuff like that. It might be possible because, yeah, normally you have seen that in the persisted type dictionary that the object itself is referenced by the by the full qualified name. So, and that means whenever this changed, so let's say whenever I move the customer, for example, from this package to another one, then MicroStream will not be able by default where to find the object again. It's important that MicroStream knows where the objects are, and then you have to change the persistent type dictionary. And this could lead to an issue, especially for using third-party library objects. So stay within the JDK, use your objects, and instead of using third-party, I would recommend to use your own object to store this. That needs to map, of course, but I would recommend this. Okay, hopefully that answers the question. And there is also a list of objects which can be used in our documentation. You will find everything on the documentation. Will we get? Okay, this is a question for the recording. Yes, you will get an email of the recording. Another question, is concurrency an issue? Should we use a synchronized version of list? That's a really interesting question, and I'm able to explain this for hours. So basically, you always are in charge to care about concurrency, basically. Within MicroStream, it's a little bit more important, I would say, but it's not that much more effort than in other applications. But yes, you are in charge to do that. You have to take care about concurrency because all of the sessions or all of the users are working on that graph. And to be honest, it's not that big issue because the access to the RAM, and for example, if multiple users iterates through a collection, for example, and one user removes one, that happens that fast that you won't have that issues. That, of course, there are possibilities that some concurrent modification exception that occur, therefore you have to deal with it. But you can use any concurrent hash map or concurrent read-write lock or stuff like that to handle that. And I think it's important to say, okay, on which collection it's absolutely needed to handle that, or are there any objects which is not that important if an exception occurs, especially a concurrent modification exception? That is up to you, but you have to take care about that. That's right. Okay, if you use a database, for example, thing as backing data store, do you need to pre-create the tables or data objects? Oh, that's a good question. I'm pretty sure that is covered within the documentation. I think there must be a table which consists of a binary file. The important thing is, even when you use a relational database, in the end you will have the same structure as on the hard disk. So it's just a binary, and maybe, yeah, it makes sense to create a table and stuff like that, but you will find that within the documentation. You have to add the information, which table is it, and stuff like that. It makes sense to have that. Okay, version of objects. So JDK is likewise stable, and custom objects are in our control. That is simple rule. Thanks. Okay, I have that. Can one use set for storing a collection or list? I'm wondering about storing unique instances. So as I said, it doesn't differ. You can use a set, a list, many different possibilities. You can use any collection type of the JDK to store it. We also provide some collection types within MicroStream, especially the new lazy list. I will come to that in the advanced training. There is a lazy list or lazy set, which can be used especially for people who want to iterate through the list or streaming through the list, and then it ensures that only a small amount of data will be loaded at once, and then it's like a paging on a pageable collection. So I would say, where we deal with eventual consistent database per service kind. How much suitable it is in case of microservice where we deal with eventual consistency and database per service kind. So maybe I could answer this a little bit later, because we talk about eventual consistency and cluster stuff and stuff like that later on. So maybe I want to move this question a little bit, and yeah, maybe you will get the answer later on. Okay, so some more questions from your side due to the object graph and creating objects and stuff like that? Okay, so then I would say let's do a short break. We are a little late, so let's move on. Let's see again on 7:15. So let's do a break about 15 minutes, and let's see again on 7:15. Is that okay for you? Then I would say see you after the short break. So, okay, let's move on. As I said, we are a little late because of that many explanations and many questions, but that's okay. During the break, there was one question I'd like to answer. It's because of the my meta objects and what collection would fit best for this. I would read the question. In my project, the data will often inserted and deleted. Which collection is more suitable? A list of my meta. The my meta has an ID field. When a new version my meta is added, I need to delete the old one. The basic operation is that finding the old one by ID, delete it if existing, and then add the new version one. So in that case, it sounds for me that fits best for a map, because you always want to find a data via an ID, via the key in case of a map. And also the fact that you have to delete the old one and create a new one, or adding a new one, I think that's best for a map in that case. There is another information of my meta is about 250,000 elements, I guess. I think it's not about the amount of elements. I would say it's about it's all about how big these elements are. Are there only small elements? Then it's okay to have them in one map, for example. If you want to split these elements a little bit, then I would recommend a tree map or a map within the map with an additional index, for example. But I think basically a map is, or a hash map is best for that. Yeah. Hopefully that helps a little bit for you. Then there was another question. It depends. It's about transactions, how to use transaction and how to handle them. So we normally use the store method, but there are some more methods built into MicroStream which can be used as a transaction. So this is normally part of the advanced training, but there is a possibility to create an eager or lazy storer, it is called. So whenever you use the storage manager, let me just jump into this. So you can see my screen, right? So yes, I shared it. So let's jump into that small example. So within the storage manager, you will be able to create, you can see this, you create an eager storer or a lazy storer object. And that means, and this is useful when you have transactions in that case. So you can create, for example, create an eager storer, which is the default storage behavior. So, and then you can say, okay, let's do it like this. Let's assign this, and then let's call it ES. It's easier to write. And on the eager storer, we are able to say, okay, ES store. And now we can hand over some objects. It doesn't matter how many objects there are, like this. And after adding all stuff, we can say es.commit. And maybe that helps you to create a transaction-like behavior in your application. It could also be used with the lazy elements. There are many other different possibilities. And there are also functions already in place to create a rollback on the data you changed during this transaction can be done. But this is part of the advanced training. And yeah, as I said, we are a little bit in a hurry to cover all the stuff within MicroStream. Okay, so okay, so let's move on to the next topic. There is one topic I like to skip a little bit because it's just a step-by-step configuration of MicroStream. The project itself, so on my side, is already in place. You can see it here, and it's already on the last branch of the project. So let me just close this. Okay, so you will find that project on that URL. So I will post you the URL to the comments. This is the step-by-step configuration, and I can show you this. There are a lot of branches available within that project. So it's basically a Micronaut project. There is the beginning, project setup done, then create a MicroStream instance, create an entity and register it, and also create a controller class. So how does it look like within the IDE? So let's get into it. That is normally the application I create together with all the participants of the training. So yeah, let's move on. We have a DB class, and this DB class initializes the storage manager. and it initializes the root object. And as you can see here, there is one builder pattern, which is which in my opinion fits best to initialize a storage manager. So you see, okay, set storage directory, I call it data again, and then I create the embedded storage foundation, and out of that foundation I create the embedded storage manager, I hand over the root, and after that I say start. By the way, this is one of the best way I would recommend to initialize this storage manager. So this has happened in the DB class. So let's move on to the data root class. There is only one list of books inside the data root. Nothing more. Let's jump into the domain objects. So we have books here with an ISBN, a name, and an author, also with a constructor, stuff like that. Let's go to the author, nothing special in it, a male, first and last name. That's really straightforward. And I think the important one is the book controller. There are two controller methods available. One is to create a book. So let's have a look at it. So there are two authors, then we have 4 books. And as you can see, we added the author directly to the book object, as it is here. Just a second, I need to let them in, so additional trainees. Okay, so we created, as I said, we created book and authors, and we added authors directly to the books within the constructor. And then we say, okay, DB root, give it a books. This is a method which is db.root. It's a method, or no, it's yes, it's directly accessed here. So DB root, give me the books, and then I use the add all method. This is just pure Java stuff. And after that, as I said, you have to store the data. You have to store the object which has changed. And in our case, the collection itself has changed. And then we call stall and hand over the collection itself. So this has happened in the create controller, and another controller which give us the books. And for those of you, it's a get just to have this within the browser. So it's not the right HTTP method to create stuff, but it's made for you to let it work within the browser. So yeah, and if you are in the branch 6 step-by-step configuration, controller creates book done, then you will be able to start this within any other IDE also. Just open the application class and say run as Java application. Then you see that the Micronaut application comes up. And I guess there is no data in place. So just a second. Let me just call it localhost 8080. You will find it here. So the server is already started on localhost 8080. So let's go there and let's say there is nothing, right? So let's say /books. So just a second. So now you can see the result is empty. There are no books in place. You can see here MicroStream is initialized. That is the initialization of MicroStream version 7.1. And when we call books, it's empty. So let's call the create method. So let's say create. Then it returns books successfully created. So it's the same like here. Now you can see it returns the string book successfully created. And now let's see if the books are really there, and here they are. These are the created books within the step-by-step project. So as I said, normally I create this project together with you, but yeah, because of the time, I skipped that a little bit. I shortened that a little bit. So, but you will find it within my GitHub repository, and feel free to check it out and use it in the same way like I did. Okay, so next topic. Let's talk a little bit about the CRUD functionality of MicroStream. And for that, I also, there is a project which is already in place. Let me just share the GitHub link to that project. So many browsers are. So let's get into it. Just a second. I have to find it. Okay, here it is. So this is the link to the next project of the next topic. So if you want, check it out to your IDE, and then you can follow this follow the code directly from your IDE if you want. So I already checked it out here, and let's go to the is that the right branch? Is it team switch to, yeah, that's the right one. So it's the same project structure like in the step-by-step demo. So instead of having a create method, I used mockup utils. So I used some mockup data, which is also part of the project. There are 2 JSON files in the mockup folder down there, 1 authors, 1 books. And I use this JSON files to load data, to load some dummy data, but all the other classes are the same. Maybe that's a little bit different. So that could also be interesting to you. In that project, I use a microstream.xml file. You could also use the normal Micronaut YAML file or application YAML file. But instead of that, I use the MicroStream XML file, which is another possibility to initialize a storage manager. Then you have the property file here. You can add some properties like the storage directory. In that case, it's again the data folder, and the channel count in this case is 4. And we can have a look after that, after starting the application. Let's have a look to the data folder. Then you will see how it's separated with multiple channels. So, okay, that's the DB class initializes the storage manager with the MicroStream XML file. It's and I said, hand over the root object as always, and that's it. So we have the data root in place. It's just a list of books with authors again. Domain objects are the same, and we have the book controller class. And as you can see here, we have to add some more code to this. And yeah, let's try to find the right code to use it within these controller classes or controller methods. Let me just okay, so here we are. So we have a list of books which they come from the load mockup data method. It's not important what is working inside here. The important thing is that we have the data here. So what has to be done to store these that list of books? Of course, as always, I say db.root.getBooks. Oh, get books, and then I will say add all to fill the data into the root object. Next step is to store that. It's the same db storage manager dot store. And always I have to store the object which has changed, and this is the db.root.getBooks. That's it. So that is one possibility to store the data which is loaded there. Okay, create a single book. Yeah, I think it's basically the same. So we are able to copy stuff from there. Let's copy the code here. Instead of using add all, I just use the add method instead of add all, and I just add the book itself instead of a list of books. But the store method itself to say, okay, I have to store the object which has changed, and in that case, it's the collection again. It's the same. Get books. Let's leave it as it is. It's already implemented, and I would say it's nothing special. But what about this? Get books with an A. And that's the point. Many people ask me, okay, how to get the data back? How to query the data with MicroStream? And now, yeah, that will be interesting. So what can we do now? How to query within MicroStream? How would you do that? So let me just Zoom tells me there is a new message, but I am not able to see it. Yeah, use Java Streams API. That's right. Getbook stream filter, exactly. Let's use this. Okay, so DB. Come on, keyboard. Do your DB storage manager. Come on, root.getbooks.stream. In that case, it's also possible to use a parallel stream because we don't want to change the data or stuff like that. So that makes sense to use the parallel stream filter. Okay, let's see. We are looking for books. Get name dot starts with an A, and then we say dot collect. Oh, come on. Collect collectors dot to list. So for sure we have to add the assign to a local variable. Let's call it books. That's it. And then we have to return the books. And that's it. Any questions to that? So we have one question, which is quite interesting. When having large collections and adding only one item to that collection, does MicroStream perform some tricks to understand that only one element was added, or does it restore all the That's right. So, but that's interesting. I need to forward this question to Florian later on. I would basically say that there is only the changed item is stored, but not really sure. So let me just forward this. Let me take a note, and I'd like to ask Florian later on. Storing whole collection. Okay, so yes, you're basically right. It's possible, basically. Maybe no benefits, but maybe yes. Okay, I would say basically it's up to you. It's pure Java. It's not a point which fits best to MicroStream or stuff like that. It's just a streaming, but you could also use the normal stream also. I think it would be much faster with the parallel stream in that case, but yeah. yeah, let's lose this one. Based on the collect. Okay, might be, yes. Okay, next one, clear books. So what about clearing stuff? So we want to clear all the books, and that's also quite easy. db root get books dot clear. So that means we clear the collection first, and then we have to start the collection. It's the same. It's the same like every time. Nothing special. Update a single book. So now this one is new. So let's say let's try to find the first book. Let's say db.root .get books stream .find first. So give me the first one, get. So let's add this. Okay, now we have the first book. Now change the set release. And now just add local date dot now. We have to store the object which has changed. In that case, we have to say db.store manager store the book itself. Okay, any question to that? It's that easy as it can be. So it's and update multiple books. This could be interesting for you. Let me just copy a few lines of that, because most of the stuff is the same. Let's say let me just, yeah, let's do this in this way. Okay, let's say we iterate through the books. Let's do it in this way. And then we say big decimal value, get price, multiply. And so that means we stream for all the books which starts with an A. And let's say for each. And then for each book, we say, okay, multiply the price and set the price. And after that, we could say, okay, we could use this method and say, okay, db.storage-manager.store, and let's say B. Okay, is that okay for you? Would you do this the same way? So it's working. So basically, it's not that wrong. So basically, it's working, but it could be better. I think I would store the collection instead. The problem is to store the collection instead would not work, because in that case, the collection didn't change. So only the books in the collection are changed. So to store the collection would not help. Yes, there is a store recursively. Yes, it is. The members of all books is stored as well. What is about exceptions on store? Okay, so I would recommend to do it this way. So let's create an eager storer. This is what I explained earlier. So let's say db.storemanager.create eager storer. And the differences between, and that was also a question, the eager storer, oh no, now I have to think about, yeah, the eager storer is the storer which stores the object and all the sub-objects below. And the lazy storer stores only the object which is handover. So, and not all the objects below. So that was also a question: is there a store recursively? It is the eager store. It does things recursively. So, and in that case, it's not necessary. But let's create the eager store. So we have that ES object, and then we can say es.store. Oh, come on. So now es.store, and after all, we can say es.commit. I think that's a better approach of changing the data. So now you will be able to do some transaction handling and exception handling and stuff like that. I think that helps a lot. There is one question under the wood: when updating an entity, will the framework walk through the available attributes or only the attribute which was changed? The default behavior is just to handle the object so the whole object instead of handling just the properties. So that is the default. So it will go through all the attributes of an object. Store B worked while I use eager loader. I could also in that specific case, I could also use the create lazy store. That would fit better in that specific case, because there is only a change on the object itself, and all the sub elements of that book are not touched. So the lazy store makes more sense in that way. Yes, of course. That's what I said. It's possible to do this also directly. So let's say db storage manager .store and then say b. That's also possible. So, but I would say it makes more sense to do this to one store on all these objects instead of storing again. This will slow down the stream. Okay. Some further question from your side. Hopefully I've answered all the stuff before. Okay, so these are the basic CRUD operation, and yeah, it's not really surprisingly that it looks all the same. And I think that's one of the best benefit of MicroStream, that it is easy to use, and you can operate directly on the object on the object graph. And I think that's the point. And one of the biggest advantage of using MicroStream, it's easy to use, and it's really straightforward. And on the other hand, it's fast as hell. So yeah, really great. Okay, let's move on. There are some more interesting stuff on the list. So let's talk a little bit about the Streams API. Some of you haven't used that streams that much in the past. There are a lot of developers. They told me, especially on some conferences, and whenever we talk, they say, okay, I never used the streams. I don't understand it completely, and it's too complicated. It's hard for debugging stuff. And so, and in some cases you are right, but that will help a lot. And therefore, I created a small presentation, especially for you to enable you or to bring you to the streams. And yeah, let's talk a little bit about Java 8 streams. It's always the same. If you don't use it that much, you have to always have a look to the documentation or to some web pages to find the right solution. But yeah, let's step into it. What is a stream? So a stream could be an aggregate operation, computes a single value from a collection of values. That's easy to find. Let's say we have a summary functionality or an average functionality. So a stream is an aggregate operation to find a single value. And this single value could be a primitive one, an object like a customer, for example, a list of customers, or yeah, void is also possible, and optional. So I think that's the most important results of a stream. A stream could also be a sequence of data elements supporting sequential or parallel aggregate operations. So I think that's kind of like the same. Yeah, but this is the definition you could find when you search for what is a stream. In easy words, I would say it's a query language for Java collections and MicroStream, because that's how to use MicroStream without a query language. So, therefore, I would say a stream is a query language for MicroStream, and it's a modern way to process collections. So, I think that's, in my opinion, the best explanation of what is a stream. And when we talk about streams, then we have to start with the easiest streams that are available. For example, an in-stream. Yeah, it is used this way. So you can say in-stream of, for example, 1 to 9, and then say for each, and it will do the stuff. So Y stands for, the I stands for a number, and then I can say system out println or stuff like that. It's really straightforward. Or you can add in-stream range, for example, and we say for each. I think it's quite understandable. So an array stream. So we are able to stream through an array of elements. So for example, we have an integer array with numbers in it. And then we can do stuff like this: stream dot of this array for each. And we can go through, then we have arrays dot stream. A lot of different possibilities to use those streaming APIs. And then we have a collection stream. And that is what we do all the time, or most of the time. Let's give me the books collection. And then I say, okay, let's do this for each. So let's do this on any object, on every object of the stream. Let's go through and print out the name of the object. Really straightforward. This is a way to process the data within an array, within an in-stream, for example, or within a collection. There are no return values in that. So is that okay for you? That is nothing special, but it's the easiest way to use streams, I would say. Let's move on. Let's talk about the collectors. So whenever we want to have a return value, we need to use a collector. So for example, when we iterate through the books, and in that case, books is a collection, and when we iterate, so we can use the toArray collector. So that means transform everything to an array and create books elements in that book array. Nothing special. A toList collector, for example. So that means go through the books, stream, and as I said, there is missing the filter. We already used that collect statement in the end. It's always the same. We call at the end of the stream. So let's say, okay, let's go through. This is the book collection. Then stream through the book collection, and the result should be collectors a list. And it's the same on the set. So, and there are many more, really straightforward. Just stream through the elements and say collected and collected to a set. A string join, that could be interesting. There is a I didn't knew this for a long time. So, but it's in some parts it's quite helpful for joining elements. So we have a list of strings, a pet list, cat, mouse, dog, and bird, and then we are able to joining this together with a comma as kind of like a CSV format. So that's interesting. Also, the string join collector. There are many more. There are just a small amount of example. So that is in most of the time, this is the end part of a stream. Then there are some other collectors. For example, the find any and find first. The find, some of you might say, okay, what is the differences between find any and find first? It works together with parallel stream and the normal stream. If you use find any, then it will find, it doesn't matter which one is find the first one, no matter which thread finds it, it returns the first one, and it differs all the time. Instead of using the first, then it will the first of the collection will be returned. Okay, some collectors always at the end of a stream, mostly at the end of a stream. Let's talk about filters. That is the part in between. So it's the same. It starts always with db root get books, for example. So with your collection, then we say stream, and then comes the filter in between the stream and the collect. So we say filter, and then we create our statement within the filter. It could be b get name starts with an a. We already have this in our application. An equals, for example. Oh, there is the equals is missing there. Okay, I have to change that. And there is another quite helpful thing. I would recommend to use this to create predicates. And it's in a lot of cases, it's more readable to do this in this way. Let's say, let's create the condition. I would say in that case, the predicate b get name equals Bangkok Dangerous, for example, and then we have an ISBN, and we want to have name and that is the it's connected with an and. So that means we have to find a book which is called Bangkok Dangerous with the same ISBN, and then we can use the name and ISBN predicate at the end within the filter condition. It's quite helpful. So whenever you need to write more readable streams, then this predicate stuff could help you a lot. Okay, what about map and flat map? What is the differences? Many people also ask this. They don't know when to use a map or when to use a flat map. That's quite easy. Whenever you have to transform the data, for example, let's say in this case, so we go through the books, we stream through the books, and we want to have a list of authors at the end, then we have to use the map. So map stands for map the result to a different result type. So that means there is only one author within the books, and then I can use map, and then I say collect collectors to list, and in the end you will receive a list of authors in that case. And flat map is a little bit different. So you have to use always a flat map if you want if there is a list of elements within your object. So let's say get all authors, stream over it, and then we say I need to have the addresses as a list, and one author could have multiple addresses, or there is a list of addresses within the author object. Then you have to use flat map. Then we can say, okay, stream through the authors, flat map stream through the addresses, and collect the addresses as a list, and that is the result. List addresses is the result. Okay, there are some stream aggregations also in place. Summary, group by, they are really specific, and most of the time I have to look for them. Yeah, it's not. I think it's I have to read it all the time or look at it all the time. In some parts, it's hard to remember this. But there are some additional sorting strings. I think it's kind of like the same, kind of like the SQL sorting, reverse order, sorted by big decimal, for example. I think these are things that are quite helpful. And that's it. And that brings me to the project, which covers all the streams stuff. Just a second. I have to find Java 8 streams. Here we are. So in that repository, you could find all the streams, and that project is already available in my IDE. You have to move to the stream impl done, and there are some classes, a book controller, exercise controller, and streams controller, and there you will find all the different examples we talked about within the presentation. I think that's pretty helpful for some of you to see the different types of streams and how to use it in combination with MicroStream. Lambda is our friend, is your friend very often. Yes, it is. Some more specific, that is an exercise which I did a lot in the past. So, okay, some questions to that topic. Okay, so it's 8. Let me just check my topics. Yeah, I forgot one topic. It's the lazy topic. Most of you or some of you might ask, okay, what about if I have terabytes of data? Do I need to have them? Do I need to have all of them within the RAM? And especially with to answer this, MicroStream provides you a lazy mechanism, and for that there is another project which is created. Just let me share the GitHub link also. Hold on, this lazy. Here it is. Okay, that is the link for the lazy demonstration. There are also multiple branches in that project. Let's start with the first branch. So let me just switch to the first one. Step 1, let's start on the master. Close all. I don't want to store it. Okay, so data root. Okay, so in that specific case, we start at persons, and in that case, when we start the application, all persons will be loaded to the RAM. Before I go on, there is one question: how are deleted objects removed? Is there some API for housekeeping? Yes, there is. there is one housekeeping, or I think there is one process which called housekeeping. But within that housekeeping, there are many smaller processes. They did different things, and one of that is to clear up the deleted object, which is let me just think about it. Is yeah, it's called housekeeping basically. You will find some more information to the housekeeping process in the documentation, but yes, that housekeeping removes the objects in the end from the storage. Okay, so let's start on the easiest approach. So we have a list of persons, and that's it. And as I said, whenever you start MicroStream, you will get all the persons in the RAM. So now let's move on to the next. To the next. Oh, before. Sorry, I have to use the presentation first. That is important. Lazy loading. Okay. So as we already say, okay, why do we need lazy loading? What data should be stored and loaded lazily? I think that's for sure important for you. How to use the lazy references, best practices. Let's talk about this. And how to release lazy data if no longer needed. There are many different topics around that lazy stuff. And it's more detailed covered in the advanced training. And I just want to mention it a little bit in the fundamentals training, because it's important to know that there is a way to load data lazily, and therefore let's move a little bit faster through the presentation. So why lazy references are important? So even if MicroStream is an in-memory database framework, that is one reason why it is so fast and performant. Of course, we are working most of the time in memory. That means best performance. The data has to be in the RAM, of course. But in some cases, as I said, it's impossible to hold data inside. And especially one important thing is binary data. You will not be able to have all the binary data. And of course, it's not necessary to have all the binary data within. So let's say images or other stuff. So binary data at all. And sometimes it's unnecessary. Yeah, that's the same. Historical data, archive data, stuff like that. Mostly it's not important to have it in memory. So we have to have a way to say, okay, which data can stay on the hard disk and which is no needed in the RAM at all. By default, the whole data will be loaded into the RAM at start of MicroStream. So that means if we have 1 million objects in the database, it will be loaded to the RAM in the end. And if you need all that data in a high performance way, you have to provide the amount of RAM to have that. It's the same like on caching machines or stuff like that. They all need RAM to be fast. And it's the same on MicroStream. But when we add some lazy references on different nodes, then only the data will be loaded, which is not lazily loaded. So in that case, you see the object 1 it's lazy loaded and it stays on the hard disk as long as it's called, or as long as you stream over it, then you will get it. And it will be loaded from the hard disk, for example, or from AWS S3 bucket, for example, if you store the data in an AWS S3 bucket. Okay, so the question is when to use lazy loading, and that is the part which is the best practice part. I would say, and I would recommend always on binary data, blobs, documents, images, and all that stuff. I recommend to use it also in a hash map, for example, because most of the time you need a description of a blob or a description of a document or a name of a document. And it makes sense to have that in a hash map or map to search for specific points. And then if you have the right document you need, then you load the document from the hard disk, for example. That makes sense. Always on binary data. Always on huge collections. with less frequented data. So let's say logs, archive data, all data which is not needed all the time, it could stay on the hard disk because no one will need it in high performance. So sometimes on collections, which huge amount of sub entities, that could also be a big issue. So you always have to think about, okay, how big is the tree below these objects? And even if I always said, okay, object graphs are great to have object graphs. In some cases, it does not make sense to have that huge graphs, because on the application side, it's, yeah, let's say most of the time you need flat data on the application side. You need to, mostly you don't need all the sub informations below an object. Mostly the object is printed in a grid, for example. You need to see the main informations of the object itself, and you don't care about all the detailed stuff below. So, and in that case, sometimes it's not a good idea to load all of them. Sometimes it makes sense to split this a little bit. Yeah, and as I said, whenever RAM is limited, you have to decide which data stays on the hard disk. And there is another point which is already interesting. When you, let's say we have 1 terabyte of data, and let's add a lot of lazy nodes on the graph. And then let's start up the application, and then we are saying, okay, now we have, let's say, 60 gigabytes on the machine. So that is the basic loading of the RAM. So, but what happens if people are starting to work with the data, loading the data and stuff like that? And that could increase your memory usage. And that's I often say, okay, if you knew that a lot of concurrent user uses one collection all the time, then it makes no sense to have this collection lazy loaded, because the collection will stay all the time in the RAM anyway, because it's used all the time and stuff like that. So this is what is important to know about lazy stuff. And this is how it looks like. So whenever you need to have a lazy reference, you can use it this way. For example, in this line, a blob image, you can do it like this. So to have it just a lazy byte image, then you have the ISBN and the name as a reference to search for it. Or you have multiple documents within, then you can use a hash map, as I said, with string and lazy bytes. You can use the image.get to get the blob out of the lazy wrapper. Then we always use the get method. This could also be a great approach to say, okay, so we have a lazy list of books, but the disadvantage in that case is whenever you iterate through the books, the whole list of books will be loaded to the RAM. So that's for sure, that's straightforward that this is the case. But it's interesting to initialize the lazy reference of the array list of books. That is the way how it is initialized. As I said, best practice for a low and medium sized collection, that is okay. The streaming and filtering, yeah, to have to load the whole lazy collection at once, but that shouldn't be a big problem. This could be a solution for huge collections, a hash map with a string. That string could contain parts of a book, for example, or parts like the ESBN. We already talked about that. Yeah, that is a solution that provides an index. Some people ask for an index with MicroStream. This is an index you can do. There are two strategies to release loaded data, manually or automatically. So whenever there is a default release strategy already in place. It releases the data on after 30 minutes, untouched. Then lazily loaded data will be released again after 30 minutes. And after reaching, I guess, 75% of the RAM of the machine, then it will be released. And there is, of course, a possibility to release it in a manual way. So, and this is shown below, lazy image.clear. And this clears the lazy reference, but you have to consider the garbage collection is important. Clearing lazy image means not that the data is gone. You need the garbage collection after. Okay, but you could find everything within the documentation regarding the lazy loading stuff. Yeah, that is what I've talked. Duration of minutes, 32 minutes or 75% of memory quota. This is the default setting of MicroStream. Okay, some more stuff, but that is not that important for now. Let me just go through the questions. Thanks. Blob suggestion, best practice, design patterns. I think I already covered this. How to handle blobs, right? Is that block suggestion? Block. Okay. Block suggestion. And now I got it. So, okay. Best practices. Yes, you are right. Or design patterns. That could help definitely. So let me take a note for that. Do not forget design patterns and best practices, of course. Okay. Is it good to use lazy for all properties? No, definitely not. So MicroStream is an in-memory database, and you need those high performant available stuff. So don't use it for everything, because your concurrent users will load the data anyway. So you have it on your application server anyway. So keep it in RAM. It saves you a lot of latency between the hard disk or between AWS S3, for example. Which impact have a crash of the JVM? Would all data be lost? Is there a sync cycle to disk storage? A crash of the JVM, I would say it's not the worst scenario, I would say, because the data is stored all the time to the storage itself. Whenever you change something in the RAM, you have to store it, and therefore there is no loss of data in that case. And in addition, there are many different backup strategies in place, and that covers the data. So most of our customers uses for example, the persistent volume of a container as the main storage, and they create backups, and this backup is written to, all these backups are written to an AWS S3 bucket, for example. So then they have different store targets. Is it possible to configure laziness of attributes changing the model object itself? Is it possible to configure laziness of attributes? What means W and O? I don't get it right, I guess. So changing the model object itself. Okay. Is it possible to configure laziness? No, it's not. No, you have to use that lazy wrapper all the time. As far as I know, it's not possible to change or to do that without that lazy wrapper. No, not possible with an annotation. As far as I know, not. So let's ask Florian, maybe he can help. Yes, yes, I know what you mean, but no, it's not possible. But it could be a great feature maybe. So add it to the feature list of MicroStream. So could be great. Beginning to import the names, kindly send. A link was dropped at the beginning for participants to import their names. Ah, okay, that is the certificate stuff, right? So let me just find the right. Oh, come on, to find the right link. It's not. Yes, here we are. Here is the link again to register for the certificate of the training. Having lazy is enough. Yes, that's right. Okay, so some more questions. Then, last but not least, I want to go to the cloud or cluster solution. Many people ask us, what about if I want to cluster MicroStream, or how to use MicroStream within a cluster, or do some replication stuff? This is all the time asked, and so we thought, okay, how can we realize a cluster with MicroStream? And the basic idea was, and now give me just a second, I have to open the another presentation with only 4 slides. Dun. Where is it? Here is it. Okay. No, that's the wrong one. Here is the right. Okay. So that means we thought about a platform to provide easy hosting of MicroStream storage. A lot of our customer uses MicroStream within a Micronaut, Helidon, or Spring application, and then they share the data via REST or via Kafka or stuff like that, and they don't want to host these applications by themselves. So so give them a possibility to easy hosting your MicroStream storage. That was a basic idea. The next idea was to provide a horizontal and vertical scaling of the data access. And on the first step, it's we thought about, okay, let's create a data replication. And yeah, the idea was born. And now the question was, okay, so MicroStream is a framework, how to realize a data service or a database service or a cluster service for a framework. And the idea was to add a standardized Micronaut template or Helidon template, or even a Spring template with an embedded version of MicroStream, which is called not the embedded storage manager. It is the cluster storage manager, and the cluster starts here in the middle with that small dot, which is called LB. We call it a load balancer, or the ingress. This is the entrance of the cluster, and how it basically works is we have multiple nodes in the background. It depends on your configuration. How many nodes do you have? There is one writer node. And then we have some event streaming stuff in the background. And this stuff does the replication of the data to the different read nodes. So that means we have one writer node and many read nodes. In that case, we provide to ensure that the data is stored in a consistent way. And this cluster provides you a high availability. So it doesn't matter how many requests you get, the performance of the cluster or of the application itself stays the same. And that was the idea behind. Okay, so the basic workflow would be download a Micronaut or Helidon cluster template, which is available within the cluster or the cloud. Create an object model within that project. Create your required REST endpoints in the controller classes. So we already did that in some projects before. Then you can add your Java business logic if you want. Basically, the project you hand over to us is your own project. So there could be business logic inside. It's totally up to you. Special stream filters, sortings, aggregation, and stuff like that. It's a little bit similar to store procedures. And you can use the non-cluster mode in your IDE for testing purposes, or the cluster will activate the cluster mode. And in the cluster mode, it tries to replicate the data, but this is stuff which happened after. Then we have our own class and cloud front end. At the moment, we provide to add the cluster to AWS, but in the future, we will add the Google and Azure also. You can choose your preferred cloud tier. So let's say a small containers with 1 replication, or small with 2 and 4. It's the same for medium-sized containers and stuff like that. You could change your template provider. So or you could change the way how to provide your template in the end. And then you will be able to adjust a lot of different security stuff and backup settings and stuff like that. And I would say, let's have a short look to that. And especially for that training, you will get a coupon. Just use the fundamentals underline 04/23. And that enables you to, let me just copy this to the chat. And you will get the possibility to start machines within the cloud. And let's do this together. So what we have here, this is the cloud front end. We'll see, you will get access when you go to cloud.microstream.1. So let me also just share this. There is a sign-up service, so just register you to get access. And in the end, you will see that dashboard with some information about trainings and news, or upcoming trainings and news for MicroStream. And there is also some stuff you first have to complete your profile, adding some payment methods or adding a coupon code or stuff like that. You will be able to manage your account, so adding some more informations about payment and all that stuff. But this is in the starter sections, you will be able to download a project template which fits best for our cluster. And one of these templates I already created for you. And this is just a second. I have to find it again. So there is one project which is called JCon 22 MicroStream cluster demo. Here is the link. It's just a small project with, I guess, 2 endpoints. At the moment, Micronaut, Helidon, Spring will be available next. And these are the 2 frameworks the 3 frameworks we will support. But there is also an idea to support many different more. Also Quarkus and GraalVM. But this is what we are working on at the moment. So at the moment, Micronaut and Helidon are the first 2. Spring will be the next, and then Quarkus and GraalVM comes. Is it only me who not see the link that Christian was pasting? Okay. Let me just check. I have to send to all of you. So maybe that helps. So let me just double check. Okay, sorry. So, okay, first I start again. This is the project which can be deployed to the cluster. This is the coupon that enables you to get a credit within the cluster, fundamentals _04/23, and then we have, this is the URL to the club. Oh, what happened all the time? He changes the receiver all the time. Okay, and this is the link to the cluster itself. So sign up, and when you go to the profile tab and to billing, you will be able to redeem the code, the coupon here. Just click on redeem coupon, and then you will be able to add this $10 credit to your application or to your cluster environment. Just to play around a little bit. And the next step would be just to check it out and see how it works. Let me do this with a short explanation. So there is, of course, there is also a documentation available. I forgot the link. So I have to find the link. Here it is. So this is the link to the documentation. Oh my God, I lost my setup. So where is it? Okay, check. Yeah. Okay, so this is the link to the documentation of the cluster itself, with some explanations how it works and how to set up, what are the most important steps to set up a cluster. So that means go to the starter, choose an existing template, in that case Micronaut or Helidon, and as I said, Spring and the others will follow soon. And before you can do that, just add or just redeem your credits here. And especially this credits, this type of credit only works for the micro replication instance, but it's totally enough for you to play around a little bit. So let's go to the cluster overview itself. And here you can add a cluster. Click on add. And so as I said, AWS and the region Frankfurt is available for now. Some other regions and also some other cloud providers will follow soon. Then in that case, you can leave it as it is. There is no possibility to change. Then you can move on to the cluster tier. And this is always, that is also what I said. There is one, just a second, I have to check the trainees. Oh, okay, I have to let them in. So, okay, so yeah, here on the cluster tier, you can choose the tier size. In that case, we have 300 millicores and 500 megabytes of RAM to 20 gigabytes of storage. And in that case, it's only one replica. So so that means replication is not available in this tier. But I think tomorrow or during the next week, all the other replications will be available. So let's choose this one. On the provisioning tab, you can choose a cluster name. Let's say CK cluster let's add a number, doesn't matter. So let's choose the application type you want to add. In my case, it's Micronaut. Then you have to add the controller path, which is deeper explained in the documentation, but especially for the project which I added to you, or it's the cluster demo, there is one class which is called, just a second, which is called MicroStream controller. And this is a class which is already in place, and it's it's necessary to have that to make it work within the cluster. And this is the path you need to have within. Oh, come on. Now so again, this one again. Okay, so now we have to add this cluster, application type Micronaut again. So let's call it my cluster. So now you have to decide how to provide the project. And in my case, I want to add the GitHub directory or the GitHub repository. Need to find it again. It's not that easy with that many Okay, here it is. Oh no, that's the wrong one. Sorry. Okay, here we are. So that is the URL. JCon 22 MicroStream cluster demonstration. Then we have one main branch. It's the main branch in that case. We want to use it. Then you could add some more informations, the amount of backups you will store, the interval of backups, cluster authentication, how to authenticate to the REST endpoints. Some proxy settings are also available just to ensure what HTTP methods are reading methods or what HTTP methods are writing methods, that the cluster knows, okay, everything that goes to post or every traffic that goes to put or delete is writing stuff and has to be managed by the writer node. So that's important. There are some other possibilities to manage that. You can do this via the URL path or via some header values to ensure that a specific traffic goes to a specific node. And then we are able to click on create. Now you see that is the cluster. And when we now click on deploy cluster, it tells us, okay, this is based on credits, and if credits are empty or are over, then the cluster will be stopped. Okay, and then it needs a little bit to start up the cluster. It takes the project out of the Git repository, and as I said, that needs a little bit something around between 1 and 3 minutes to start up the whole cluster or the whole application. Let's wait. So let's just have a look to your questions. Create CRUD Micronaut MicroStream starter code with MicroStream CLI domain language. That is a link. Okay. Hello, does a form link to fill in order to give feedback. So I already posted the link. Just a second. I will do it again. Here we are. So here there is a form you can fill to all of you. Okay, here it is. Okay, some other questions so far. Okay, now you can see the namespace is basically deployed. You see the namespace ID is available, so that means that the cluster starts up properly. let's wait for the status running and the available nodes. And then we could have a look to the to the structure itself. There are some restarts needed, and that's why it needs a little bit. Okay, let me just check. Some more questions so far. So there are a lot of more topics regarding MicroStream, especially for many people ask us how to handle data changes, data structure changes, to be in detail. And Marcus already explained that there is a legacy type mapping in place, which works mostly like the normal changes. But these topics are stuff for the advanced training, and it will be covered by the advanced topics. Okay, now the cluster is up and running. So let's move into the details of the cluster. Now let's check. So it seems that the writer node isn't fully started. So let's wait a little bit. Okay, there is a block for J. Okay, but that doesn't matter. Let's have a short look on the possibilities you have here. You have a backup configuration, or you can change. There are some backups which can be downloaded off the storage. So you will be able in the end to up and download the storage to update or to do backups. In that case, there is monitoring which is still in place. So that means it enables you to see, okay, how is the RAM usage of the application itself? And I think especially in the simple setup of a single node, you only have the node here, and the backup proxy creates the backups. So we have logging already in place. If you need to see what happened within the cluster, you can see it here. A lot of different stuff is going on. Just try it out. Just register, just deploy. If you want, you can use my project, or you can use my project as a template to deploy it with your stuff. Let's have a short look. So let's call the cluster. That's also important. Let's see if it's working. So let's call the UL, and as you can see, you will get an empty result. But to be sure, we have to have a short look to the application itself. So that's the Git repository of the demo. Oh, here we are. So now you can see this is the controller class. There are it's all about products in that case, and there are only some few controller classes in it. One is the get all the products, or update it, or insert. And in that case, I used there are no products. So, and I have to use my postman to call the add. So let's just check cluster calls. So this is the add. It's a put method, and I have to add the URL, and let's send. Just a second. There is one thing on my network at home. Okay, now this is working. You can see you get a status 200. And now when we call this again, do you see it's stored and it's available, and we could add another one and stuff like that. So as I said, all over, it's a service for you that prevents you from all that Kubernetes stuff and just have an easy way to deploy your data provider. You have the possibility to have replication in place. There are a lot of more stuff around the cluster, but there will be an additional training available, especially for the cluster. And yeah, I would say just not really right in time, but I think especially for version 8, I will hand over to Florian to see what's new in version 8. So Florian, are you there?
Yeah, hi, I'm here. So today we finally released the last official MicroStream release, version 8. The last official one, because a lot of you maybe know right now that we are moving the code base over to the Eclipse Foundation, and therefore it's the last official MicroStream release from our side called MicroStream. Afterwards, it will be the same code base, of course, but it's under the Eclipse Foundation's roof, and there are a few name changes going on. The new name will be Eclipse Store, and we put out the serializer project as a separate one called Eclipse Serializer, and therefore the further upcoming releases will have a different name, probably different versions, but the code base, like I said, it's going to be continued from the current development point on. So in a version 8, the highlights, of course, are the upgrade to Java 11. So we moved our code base from Java 8 to 11, and it's you have to use Java 11 or newer to use MicroStream. Just don't forget to update your Java version if you're still on Java 8. Therefore, we have a proper support for the Java module system with proper export and import definitions. It can be integrated seamlessly in module projects if you got any. And the big other features are the lazy collections. It was asked quite a lot in the past. The lazy collections are implementing Java util collection interfaces like list, map, and set. And under the hood, we use lazy loading to segment the collections, and you don't have to load the whole array list, for example, if you got millions of entities in a single list into the RAM. That will be done internally in the collection, so you don't have to worry about the lazy loading inside big lists anymore. It can be configured how big the segments should be, and different other stuff. And so you can put a very huge amount of data in a single collection without worrying to bloat your memory. And all the lazy loading is hidden under the scenes. The Quarkus integration is final in the 8.0 release. Currently, we're supporting Quarkus version 2. Quarkus released version 3 today, actually. That's the next step. In the next release, we'll upgrade to the next Quarkus versions properly. I think we will do a second integration where you can choose what Quarkus version you want to use, like we did in our other integrations with the CDI or Spring Boot. So Spring Boot, we did a lot of bug fixing and small features like multiple storage managers, as well as type handler improvement for Java 17. There are some collections which are used by the new factory methods over the last few Java releases, like list of or set of. And these are not public classes. These are internal private hidden stuff, but most of them are immutable. So we had to implement special type handlers for that. But now all the Java 17 collections which are created by a factory method of the newer Java versions are supported, all the immutable stuff. So the type information with the serializer. What about serializer with or without type information? Okay. The serializer itself is doesn't hand over the type dictionary or the information how the stream is built up. So we have to manage the type dictionary on both sides to ensure you got the right type handlers for the serialized data. But if you want to send over the type information, which types are used inside the streams, that can be done with version 8. And so you can only update, for example, one, or you have to register on one side all the types, and the other side gets the type information handed over by the stream. This is a security issue, of course, because you don't want to see the type information in your data stream. So we recommend it to use only in secured environments, for example, in your cloud environment or in your protected network of some sort. But if you're communicating over public networks, we recommend to use the standard serializer and handle the type handlers on every site which takes part in the communication. That's the point of a serializer with type information. Yeah. And another cool tool we did is it's a bit of a misnomer here, channel count migration. Basically, it's a storage migration tool. So you can migrate from one configuration to another, for example, to a different storage target from the local hard drive to cloud storage. Or different storage target, and you can change the configuration itself. For example, you can change the channel count. So if you want to update your channels from, let's say, 4 channels up to 16 because you're moving to a bigger machine, the storage can be migrated with this tool. It's just a simple main method which takes arguments. So we can call it within a CI or CD. A train, or can automate it to get your storage migrated. So and you don't have to move, for example, the storage from your local hard drive to a different storage target to migrate the channels. Just use a different folder on your hard drive, and you can do it on the same storage target, of course. So these are the highlights of the version 8. We released 2 early access versions already for trying out. We got a lot of feedback and even pull requests which added some stuff or fixed some issues. And that's the way we will do it in the future as well. So we release early and release often, just for all people are interested to try out the new features in beta stage and so on. And we will be happy to receive the feedback over at the Eclipse projects. So got a few questions here. I see Eclipse 0.1 will be the next release. We have to release the version 1.0 first. We cannot start with version 9.0, for example, because of the Eclipse guidelines. So the version 1 will be basically MicroStream 9.0, if you will. Yeah. I see another question. Christian answered it already. So you don't have to think in 1 to n or n to m. relations anymore, like in a database. Just use Java pointers, put a list in an object for, yeah, Christian wrote a client with a list of companies, or if you have a customer there, you can hold a list with purchases from a customer and so on. And that's a different way of thinking. Don't think in a relational way anymore with the 1/n and n-to-m stuff. Just design your data model in pure Java like you would without any data storage in the background. And that's the only data model you have to worry about anymore. And that's the beauty of staying in pure Java without having to worry about some mapping to a different data model. Yeah.
Okay, Florian, thank you. There is one question about the read-only access, which is also part of the changelog here, but this is only halfway to the functionality. It's basically a read mode, yes. That is a way to disable write requests, for example, within a cluster, to ensure that there is no possibility to write to access a write, because it cannot be replicated at the end. But it's not a read-only mode for accessing one storage from multiple JVMs.
Yeah, not yet. So the first step to the multi-VM to a single storage approach, but that was part of the feature set we needed for the cluster. So the read nodes are blocked from writing, and that's a way to ensure that not a different node writes to the storage cluster and causing discrepancies. And what you can use it now for is for, let's say, legacy applications which are only running in the read mode and shouldn't change the data anymore. Or depending on a user, if you connect the user to an application which only have read writes, let's say a different software which fetches data from outside, a CRM tool, or any different software which just should have read access to the data, there you can switch your storage manager or a different client to a read-only mode and ensure that no external system changes your data. Yeah.
And in addition, Florian, there was one a question, and it's about storing a collection. When we change one object of the collection and we call store the collection, is the whole collection stored again, or is it just the added object? That was one question from earlier.
It depends. If you change an object in a collection, the only thing you have to do is to store the changed object.
That's right.
If you add or if you modify the collection itself, let's say you remove an object or you delete, you add an object or change the order of objects, for example, then you have to store the collection. The collection pointers, all the object IDs are written anew, but the containing objects not. So that's not a problem. You don't get a really huge amount of data.
Okay, that was the point why we are asking. Yes, yeah. Okay. Okay, there is another question. Is there a way to change a read node to write node if the write node is not available? That is done within the cluster automatically. So whenever the write node is not available, the next read node will become the next writer node. So that is handled within the cluster automatically. Okay, great. I guess we covered the last question. So, Marcus, have you anything to say to at the end of the training, or is there anything you want to mention?
So you want me to expand the training, right?
So there are 4 minutes left. So
I see there's one more question coming on.
okay.
General question, I understood the binary file is written continuously. So when MicroStream accesses, it starts at the end of the file always. Yeah, that's true. MicroStream never overrides existing files, and therefore no data loss can happen. Depending on the configuration and the file size of the storage, either it's written appended to an existing file or into a new one. And if data becomes obsolete or not reachable anymore, basically deleted from the storage, or older versions of data, so your storage doesn't grow indefinitely. There's the housekeeping running in the background and basically defragmenting the storage files, and it writes the storage files newly without the deleted elements. And when a storage file only consists of elements which are not needed anymore, then the file can be safely deleted. But a file is never overwritten at any time, and that's one aspect why there can't be data loss on a hardware level. And if you put override files, we had to ensure on up to the single byte that it's correct. And if something goes wrong, if you have package loss in network and so on, the storage can be corrupted. So that's why we're doing the append writes only. Yeah.
Yeah, there is another question. When a structure element is lazy, anything below will be true. Yes, that's the case. So
Store all, yeah, if the lazy is loaded. If the lazy is loaded in memory, and only then it can be changed and should be written anew. So depends. So the store all, we have to differentiate here. The store all doesn't store eagerly. Store all is just a shortcut for multiple single store methods. If you want to store multiple objects at once. If you want to do an eager store, meaning all the referenced objects are stored as well, you have to use an eager store for that. Yeah. But it's in a documentation under storing data. What's the difference between lazy storing and eager storing?
Yeah, I already explained that a little bit. So lazy is the default strategy, and eager stores everything below the stored object. So yeah, and it's also covered again within the advanced training. So just a second, I have to check this. When is the advanced training? So the next advanced training is May the 16th. No, part 1. Sorry, May the 9th. The 9th. 9th of May. Okay. So if you are, for sure there are some more questions. So based on that, feel free to send us an email if you have further questions. If you have questions regarding the implementation or how to migrate your data, just let us know. It's also possible. It's always possible to make a small appointment for a short meeting. So some of our customers do that a lot and ask us many different questions. So feel free to do that the same.
yeah, good places. All of the GitHub discussions,
Definitely,
probably
yes.
the fastest way.
Yeah. Of course. Thank you, Flo. Okay. So it was a great pleasure to share my evening and afternoon with you. Hopefully you enjoyed the training, and hopefully MicroStream is a great opportunity for you to create new projects and instead of using regular databases. So yeah, from my side, I would say thank you, and stay healthy, and hopefully see you on the next advanced training. Yeah, that's it. See you and goodbye. Thank you.